Okay, so good day everyone. So today we will solve sample problems regarding Bernoulli's differential equation. So we have here 5 sample problems that we will solve. Let's start with our first problem. We have y prime plus xy equals xy squared. So again, let us convert this into our Leibniz notation. So that would be derivative of y with respect to x plus xy equals xy squared. And after that, we must determine our value of p of x, q of x, and our exponent. So our p of x here is just x. Our q of x is also x. And our exponent here is 2. After that, we determine our integrating factor. That would be e raised to the integral of 1 minus n p of x dx. So that would be e raised to the integral of 1 minus 2 p of x, which is x dx. So 1 minus 2, that would be negative 1. So negative x dx. And eventually that would be e raised to negative x squared over 2. And since we now have our integrating factor, so we can have our general solution. That would be y raised to 1 minus n multiplied by your integrating factor equals integral of 1 minus n. Okay, so our n is 2 and our q of x is x. Okay, so I think for our general solution, okay, that would be 1 minus n. We also have our integrating factor here multiplied to q of x dx plus c. Let's simplify the equation. That would be y raised to negative 1 multiplied to e raised to negative x squared over 2 equals, that would be negative integral of e raised to negative x squared over 2 x dx plus c. So to integrate this one, we will let u to be negative x squared over 2. And the derivative of u would be negative 1/2 multiplied to 2x rather. Or that would be negative x. But eventually, our negative sign is here, and we already have our x on the inside function, so we can put it inside. That would be integral of e raised to u. Okay, this would be dx. Okay. So let's just transfer the negative sign here on the inside, and that would be du plus c. And our final answer would be y raised to negative 1, e raised to negative x squared over 2 equals, that would be e raised to u, which is also e raised to negative x squared over 2 plus c. Okay, so if you further simplify this one, or if you want, actually this can be our final answer. But again, if you want to get the explicit solution for your answer, so we can divide. Okay. So we can divide e raised to negative x squared over 2 to our whole equation. So that would be y raised to negative 1 equals 1 plus c e raised to x squared over 2. And eventually, since this is a reciprocal or y raised to negative 1, that would be y equals, so the reciprocal of this would be 1 over 1 plus c e raised to x squared over 2. So this is our explicit solution. Okay, next example. We have y prime plus xy equals 6x square root of y. So again, let's convert this one into our Leibniz notation. That would be derivative of y with respect to x plus xy equals 6x y raised to 1 half. So our p of x would be x. Our q of x would be 6x. And our n is 1 half. So let's get our integrating factor. That would be equals e raised to the integral of 1 minus n p of x dx. So 1 minus 1 half, that would be 1 half x dx. And eventually that would be e raised to 1 half multiplied to x squared over 2. And that is e raised to x squared over 4. Then since we already have our integrating factor, we can have our general solution. That would be y raised to 1 minus n multiplied to our integrating factor. That is e raised to x squared over 4 equals integral of 1 minus n integrating factor multiplied to our q of x, which is 6x dx plus c. So let's simplify. This would be y raised to 1 half e raised to x squared over 4 equals 1 half integral of, okay, let's include the 6 here. So 6 over 2, that would be 3. And this is e raised to x squared over 4 x dx plus c. So again, let's use our u sub. So if we let u is equal to x squared over 4, so your derivative of u would be, okay, 1/4 multiplied to 2x. And that would be x over 2 dx. But we only have x dx here, so it means that is 2u, 2 du would be equal to x dx. So our resulting differential equation would be y raised to 1 half e raised to x squared over 4 equals 3 integral of e raised to u, then that would be 2 du plus c. And if we further simplify this one, this would be y raised to 1 half e raised to x squared over 4 equals, okay, we'll multiply the 3 with the 2 here on the inside. That would be 6 e raised to x squared over 4 plus c. So this is our answer. So again, if you want to check your explicit solution, so that would be y raised to 1 half e raised to x squared over 4 equals 6 e raised to x squared over 4 plus c. So you just divide the whole equation by e raised to x squared over 4. So that would be y raised to 1 half equals 6 plus c e raised to negative x squared over 4. Then square root the whole right side. Okay, main square root. Uh, your square root is y. No? So it means if we multiply 2 to the whole equation, or raise the whole equation by 2, we can eliminate your 1/2. So that would be 6 plus c e raised to negative x squared over 4 squared. So this is your explicit solution. Okay. Next, we proceed to our next example. That would be x, derivative of y with respect to x, plus y equals 1 over y squared. So again, let's convert it to our form. This would now be y raised to negative 2. Divide the whole equation by x. That would be derivative of y with respect to x plus 1 over x multiplied to y equals y raised to negative 2. So this time we determine our p of x. That would be 1 over x. Our q of x, okay, you do not have any term here on the coefficient, so it means our q of x is just 1 and our n is negative 2. So for our integrating factor, that would be e raised to the integral of 1 minus n, or plus 2, since minus of the negative number, multiplied to 1 over x dx. So that would be e raised to 3 dx over x, resulting to e raised to 3 ln of x. Then this would be e raised to ln of x cubed. And eventually, our integrating factor would be just x cubed. Then we have our general solution. So that would be y raised to 1 minus n, or 1 plus 2, multiplied to our integrating factor equals integral of 1 plus 2 multiplied to our integrating factor multiplied to our q of x dx plus c. So that would be y cubed x cubed equals, that would be 3 x cubed to the 4th over 4 plus c. So this is our final answer. So again, if you want to check on the explicit solution of our differential equation, so this would be, okay, so you just divide the whole equation by x cubed. That would be y cubed equals 3/4 x plus c x raised to negative 3. And eventually this would be y equals 3/4 x plus cx raised to negative 3 raised to 1/3. So that is our explicit solution. Okay, next example. We have t squared multiplied to derivative of y with respect to t plus y squared equals ty. So again, convert it to our form. That would be t squared, derivative of y with respect to t, plus y squared equals ty. So you have your y squared here. Again, all the terms having y raised to n, you must transpose it to the right side. And all the terms containing y raised to 1, you must transpose this one to the left side. Okay. So that would be t squared, derivative of y with respect to t. Okay, this would be minus ty equals negative y squared. Then we divide the whole equation by t squared to isolate your derivative of y with respect to t. So that would be minus 1 over t y equals negative 1 over t squared y squared. Then we determine our p of t and q of t. So your p of t, that would be negative 1 over t. Your q of t would be negative 1 over t squared. And your n would be 2. Okay, then we have our integrating factor. That would be e raised to the integral of 1 minus n. Okay. Your p of t, that is negative 1 over t dt. Simplify, that would be e raised to negative 1 multiplied to negative 1. That would be positive. So dt over t. So this would be e raised to ln of t. And eventually, our integrating factor is just t. Then we substitute it to our general solution. Our first term is y raised to 1 minus n multiplied to our integrating factor equals integral of 1 minus n multiplied to your integrating factor multiplied to your q of t, which is negative 1 over t squared, then dt plus c. So this would be y raised to negative 1 t equals. So this is negative 1 multiplied to negative 1. That would be positive. So that is just integral of dt over t plus c. So this would be y raised to negative 1t equals ln of t plus c. So that is our final answer. So if we want to check on the explicit solution, okay, so you divide t to the whole equation. That would be y raised to negative 1 equals ln of t plus c over t. And get the reciprocal. That would be t over ln of t plus c. So that is your explicit solution. And the last example, okay, we have this one. Again, let us convert this into our general form. So 3 multiplied to 1 plus t squared. Derivative of y with respect to t equals. Okay, so let's transpose your 2ty to the left side. So this is minus 2ty, y cubed minus 1. Let's distribute this first. So 3, 1 plus t squared. Okay, we distribute, that would be 2ty to the fourth plus 2ty equals 0. So again, the term having y raised to n, we transpose it to the right side. So this one. 3 multiplied to 1 plus t squared, derivative of y with respect to t, plus 2ty equals 2ty raised to 4. Then we divide the whole equation by 3 multiplied to 1 plus t squared. So the resulting term would be derivative of y with respect to t plus 2t over 3, 1 plus t squared y equals 2t, 3, 1 plus t squared y raised to 4. Next, let's determine our p of t. that would be 2t over 3, 1 plus t squared. Our q of t is the same function. That would be 2t over 3, 1 plus t squared, and your n is equal to 4. Next, let's solve for our integrating factor. That would be e raised to integral of 1 minus n multiplied to your p of t, which is 2, or 2/3 multiplied to t over 1 plus t squared. Then that would be dt. Okay? So let's factor out all the coefficients first. So 1 minus 4, this would be negative 3. So negative 3 multiplied to 2/3, that would be negative 2. This is t dt over. So I'll just make this t squared plus 1. So if we let u to be t squared plus 1, your derivative of u must be 2t dt. So it means we need 2 here on the numerator. So we have 2 on the coefficient. So let's just move this one inside. This is e raised to integral of 2t dt over t squared plus 1. So this would be e raised to negative ln of t squared plus 1. And eventually, e raised to ln t squared plus 1 raised to negative 1. And our integrating factor would be t squared plus 1 raised to negative 1. Let's put it in our general solution. Y raised to 1 minus n multiplied by our integrating factor, t squared plus 1 raised to negative 1 equals integral of 1 minus n. Again, multiply it to our integrating factor, t squared plus 1 raised to negative 1 multiplied to our q of t is 2t over 3, 1 plus t squared dt plus c. So let's simplify. This would be y raised to negative 3, t squared plus 1. So this would be negative 3. So again, multiplied to 2/3, that would be negative 2. And since this is negative 1, so let's just transpose it to, or let's just move this into the numerator. That would be now t multiplied to t squared plus 1 raised to negative 2. So again, if we let u to be t squared plus 1 and your du is 2t dt, so again, you need this 2, no? So that we can have our derivative of u with t dt. So that is just power rule. So negative t squared plus 1 raised to negative 2. Okay. I'll put your 2t dt here. Then eventually, this would be y raised to negative 3, t squared plus 1 raised to negative 1 equals negative. So this would be t squared plus 1 raised to negative 2 plus 1 over negative 2 plus 1 plus c. And our final answer would be y raised to negative 3, t squared plus 1 equals. So this would be negative 2 plus 1 is negative 1. So t squared plus 1. So negative 2 plus 1, negative 1 plus c. Okay. So if we convert this one into your explicit solution, this would be 1 over y cubed. equals. So just divide the whole equation by t squared plus 1 raised to negative 1. So this would be 1 plus c t squared plus 1. Okay. And eventually this would be y equals, okay, reciprocal and you have here 1/3. So that is your explicit solution.